Welcome, friends of the natural world. Join me as we journey down into the ocean's mysterious depths, a realm covering over 70% of our planet, yet still largely unknown. Here, in the darkness and crushing pressure, life thrives in forms stranger than we ever imagined. Prepare to leave the sunlit world behind as we plunge into the unknown deep, where the rules of life are rewritten. Let our expedition begin. As our vessel descends, sunlight fades and we cross into the twilight zone, a world of perpetual dusk. Deeper still, we enter the midnight zone, where darkness is absolute and only bioluminescent creatures create light. Here the water is near freezing, life moves slowly, and every morsel of food is precious. In this world without sun, survival depends on adaptation and resilience. We descend into the abyss, leaving the world above far behind. At 6,000 meters, the pressure is immense, the darkness total. Life here is strange and resilient. Why do we explore such a hostile place? Curiosity drives us, as it always has. The creatures here are masters of survival, true aliens of our own planet. Let us prepare to meet them. Our submersible's lights cut through the blackness, revealing a world shaped by crushing pressure. Here, 10,000 meters down, we meet the Mariana snailfish, a ghostly, translucent creature. Its soft, gelatinous body yields to the pressure, thriving where others would shatter. It swims with slow, undulating grace, perfectly at home in the abyss. Despite its delicate look, it is the apex predator here, hunting amphipods with powerful suction. The snailfish's secret, a special molecule, TMAO, lets its cells survive the crushing depths. As our lights scan the seafloor, we spot a flurry of shrimp-like creatures, supergiant amphipods, Alicella gigantea. They swarm in vast clouds, growing up to the size of a dinner plate, a phenomenon called abyssal gigantism. As scavengers, they rush to any food that drifts down, breaking it down and recycling nutrients. Amphipods are a vital link in the hadal food web, fueling life in the ocean's deepest trenches. Let us now adjust our focus, moving from the larger inhabitants of the trench to the microscopic. The soft, silty sediment that carpets the floor of the hadal zone is not just mud. It is a living landscape. If we were to take a sample of this sediment and examine it under a microscope, we would discover a world of breathtaking complexity and beauty. We would find countless single-celled organisms known as foraminifera. These are protists, not animals, but they play a vital role in this ecosystem. They are among the most abundant life forms here, creating intricate shells or tests from organic materials, agglutinated sediment grains, or calcium carbonate. What is truly astonishing about the hadal foraminifera is their structure. They build their tiny, chambered shells with microscopic precision. Some resemble miniature snail shells, Others look like delicate branching corals, and some are perfect geometric spheres. In the darkness of the trench, they construct these architectural marvels from the sparse materials available. Many of the species found here are unique to the hadal zone, having evolved in complete isolation. Because they cannot use calcium carbonate, which dissolves under the intense pressure, many deep-sea foraminifera build their tests by gluing together tiny particles of sand and silt, creating a mosaic-like casing that protects their single-celled body. These tiny organisms are not passive inhabitants. They are active grazers, extending fine, sticky strands of cytoplasm called pseudopods out from their shells. These pseudopods form a complex, sprawling web in the sediment around them. This web acts as a trap for even smaller prey, primarily bacteria. The foraminifera slowly digest any bacteria that become stuck in their nets, absorbing the nutrients. In this way, they are the microbial gardeners of the hadal zone, harvesting the bacterial lawn that grows on the marine snow. They are a crucial link between the bacterial level of the food web and the larger organisms that might, in turn, consume them. The study of these foraminifera provides us with a window into the past. Their tiny shells are incredibly durable. As they die, their tests become part of the geological record, forming layers of sediment that can be dated back millions of years. By analysing the types of foraminifera found in different sediment layers, scientists can reconstruct the history of the deep ocean. They can learn about past climate conditions, ocean chemistry, and the evolution of life in the trenches. These humble, single-celled organisms are not just survivors. They are chroniclers, silently recording the long, slow history of the deepest, darkest corners of our world for us to one day read. Our lights reveal a mysterious eel-like fish, the macrourid, or rat-tail, hovering in the hadal depths. Once thought absent here, these fragile creatures challenge what we know about life at extreme depths. Adapted to darkness and crushing pressure, they sense the world through smell and vibration. Each sighting reminds us the hadal zone still holds secrets, waiting to be discovered. Deep in the Puerto Rico Trench, at nearly 8,400 meters, lives the hadal cusquil, Abyssobrotula galathiae. Pale, slender, and nearly blind, it survives by conserving energy, lying motionless or buried in sediment, waiting to ambush prey. Each deep-sea trench is its own world, with unique creatures and survival strategies. The deep is not one world, but many. In the sunlit ocean, colour and pattern are tools for survival. But in the pitch-black hadal zone, invisibility is key. Here, creatures like the ghostly Mariana snailfish have lost their pigment, becoming translucent to blend into the darkness. The only light comes from bioluminescence, flashes and glows that serve as camouflage, defense, and communication. In the deep, light is a secret language, flickering, fading, and illuminating life where the sun never reaches. At 10,000 meters, pressure would crush any surface creature. But deep-sea life, like the Mariana snailfish, thrives here. Their bodies are soft, gelatinous, and filled with water. No gas spaces to collapse. Special molecules like TMAO protect their cells and proteins from being crushed. Even their bones are flexible, built to bend, not break. These creatures are living submarines, perfectly adapted to the deep. In the eternal darkness of the deep ocean, sight is nearly useless. Many hadal creatures, like the cusk eel, have lost their eyes entirely. Instead, evolution has enhanced senses like touch, vibration, and smell. These fish use lateral lines to feel movement and chemical cues to find food and mates. In this world, life thrives by sensing what we cannot see. The deep sea is a world defined by scarcity. Food is rare, arriving unpredictably from the sunlit world thousands of meters above. The water is intensely cold, hovering just above freezing. In response to these conditions, life in the hadal zone has adapted to run in slow motion. The metabolisms of these creatures are incredibly slow, a strategy known as metabolic rate suppression. By burning energy at a much lower rate than their shallow water relatives, they can survive for extremely long periods on a single meal. This slow pace of life isn't a choice. It's a fundamental necessity, a crucial adaptation for existing in a low-energy world. This slow metabolism affects every aspect of their lives. Hadal creatures grow at a glacial pace, taking many years, sometimes even decades, to reach maturity. Their movements are often slow, deliberate and efficient, designed to conserve every possible calorie. We see this in the patient, sit-and-wait hunting style of the cusk eel, or the gentle, undulating swimming of the snailfish. There are no high-speed chases here. Energy is just too precious to be wasted on pursuits that aren't guaranteed to succeed. Life is a marathon, not a sprint, and every action is carefully calculated in a strict energy budget dictated by the cold and the dark. This slow pace of life also leads to remarkable longevity. Many deep-sea animals are among the longest-living creatures on Earth. While the exact lifespan of hadal species is difficult to determine, their relatives in the slightly shallower abyssal zone, like the Greenland shark or the orange ruffy, can live for centuries. It's highly likely that the inhabitants of the hadal zone also have exceptionally long lifespans, their lives unfolding over vast stretches of time that are, honestly, difficult for us to imagine. They're born, they grow, they reproduce, and they die in an unhurried rhythm, their entire existence tuned to the slow, steady pulse of the deep. This slow lifestyle also has consequences for their resilience. Because they grow so slowly and reproduce infrequently, hadal ecosystems are incredibly vulnerable to disturbance. A population that's damaged may take hundreds or even thousands of years to recover, if it recovers at all. Their slow-burn existence is a perfect strategy for a stable, unchanging environment. But it makes them fragile in the face of rapid human-induced changes like pollution, deep-sea mining, or climate change. Their unique adaptation for survival, this deliberate pace of life, is also their greatest vulnerability in a world that's beginning to change faster than they can possibly adapt. In the vast, three-dimensional blackness of the hadal zone, the challenge of finding a mate is a monumental evolutionary hurdle. The population densities are incredibly low. An individual might swim for a very long time without ever encountering another of its own kind. For life to continue, creatures have had to evolve some of the most bizarre and fascinating reproductive strategies on the planet. For many, reproduction is the single most important event of their long lives, and they've developed extraordinary adaptations to ensure they don't miss the opportunity when it finally arises, ensuring their genetic legacy continues in this lonely, extreme world. One of the most extreme solutions to this problem is a strategy known as sexual parasitism, famously practiced by some species of deep-sea anglerfish. When a tiny male anglerfish finds a female, which can be thousands of times his size, he bites onto her body and never lets go. Over time, their bodies physically fuse together. His circulatory system connects to hers, and he becomes a permanent appendage, losing his own eyes, fins, and digestive organs until he's little more than a parasitic sperm factory, providing fertilization on demand. This ensures that the female, once she finds a mate, never has to search again, a truly profound adaptation to the loneliness of the deep. Other creatures rely on their highly developed chemical senses. They release specific pheromones into the water, powerful chemical attractants that can travel for long distances on the slow deep-sea currents. A potential partner with the right receptors can follow this chemical trail back to its source, a scented pathway leading to a mate in the endless dark. Bioluminescence can also play a role. Some species may have unique light patterns that act as a beacon, advertising their species and gender to any potential mates who might be gazing out into the darkness. It's a lonely heart's advertisement written in the language of light, flashing a message of availability across the abyss. Another common strategy is to simply change sex. Many deep-sea fish are hermaphrodites, meaning they possess both male and female reproductive organs. Some are sequential hermaphrodites, starting life as one sex and changing to the other as they mature. Others are simultaneous hermaphrodites, able to function as either male or female at any given time. This doubles the chances that any encounter with another member of their species will be a fruitful one. These varied and incredible strategies, from parasitic males to chemical love letters, all highlight the immense selective pressure that the darkness and emptiness of the deep sea place on the continuation of life itself. In the hadal zone, life faces a single overwhelming challenge: crushing pressure. At 10,000 meters deep, the force exceeds 1,000 atmospheres, more than a ton per square centimeter. This immense force shapes every aspect of life, warping proteins, compressing cells, and demanding radical adaptation. Hadal creatures are soft, gelatinous, and liquid-filled, perfectly balanced against the pressure. They are masterpieces of adaptation, shaped by the relentless weight of their world. In the hadal zone, life faces not just crushing pressure, but the tyranny of absolute cold. Temperatures hover just above freezing, slowing every chemical reaction and movement. Only cold-blooded creatures survive, their bodies adapted to this relentless chill. Life here moves in slow motion, with growth and reproduction stretched over decades. The cold is not just a challenge, but a force shaping the extraordinary forms of the deep. In the sunlit world, life thrives on light. But in the hadal zone, 10,000 meters deep, there is only darkness. No plants, no sunlight, and a constant famine. Life here survives on a slow rain of marine snow, tiny particles drifting down from above. Rarely a whale fall brings a feast, triggering a frenzy among scavengers and predators. In this world, survival means waiting in the dark, hoping for the next meal to arrive. In the vast, silent darkness of the hadal zone, life faces not just crushing pressure and cold, but profound solitude. Here, creatures are scattered, encounters are rare, and finding a mate is a monumental challenge. Evolution has driven extraordinary solutions. Chemical trails, bioluminescent signals, even fusing together for life. In the deep, the drive to connect shapes life in remarkable ways. For millions of years, the hadal zone has been a stable, isolated world. But now human intrusion is casting a long shadow, threatening these fragile ecosystems. Pollution, like microplastics and toxic chemicals, is reaching even the deepest trenches. Deep-sea mining could smother entire communities and disrupt this silent world. These ancient, slow-growing ecosystems are exquisitely vulnerable. Our responsibility is profound. Protect these irreplaceable worlds. We often call rainforests the lungs of our world, but the ocean is the other, even larger lung. It produces over half the oxygen we breathe, thanks to trillions of phytoplankton performing photosynthesis at the sunlit surface. The ocean is also a vast carbon sink, locking away carbon in the deep sea for thousands of years. Protecting the ocean means protecting the systems that make our planet habitable. We must see the ocean as a living partner in maintaining a stable, breathable world. The extreme environment of the hadal zone has acted as a powerful evolutionary forge. For millions of years, it has subjected life to pressures and conditions found nowhere else on Earth. The creatures that have survived this trial are not just curiosities, they are living libraries of unique biological information. Each species holds within its genetic code a set of solutions to some of the most difficult problems life can face. How to function without light. How to withstand crushing pressure. How to survive in absolute cold and near total starvation. The answers are written in the DNA of the snailfish, the amphipod, and the cusk eel, waiting for us to learn. how to read them. Consider the remarkable molecule trimethylamine N-oxide, or TMAO. This is the compound that the Mariana snailfish uses to protect its proteins from being destroyed by pressure. Understanding the precise mechanism by which TMAO stabilizes cellular structures could have profound implications for human medicine and biotechnology. It could lead to new methods for preserving human organs for transplantation, or for stabilizing therapeutic drugs and enzymes to make them more effective and longer-lasting. The biochemical secrets of a small ghostly fish from the bottom of the ocean could one day help save human lives, a gift from a world we are only just beginning to know. The adaptations of hadal creatures could also inspire new materials and technologies. The flexible, pressure-tolerant skeletons of deep-sea fish could provide blueprints for designing new submersible vehicles or deep-sea equipment that can better withstand extreme environments. The highly sensitive chemoreceptors of giant amphipods, which can detect minute concentrations of chemicals from great distances, could inspire the development of new environmental sensors for detecting pollutants. The ocean, and particularly its deepest parts, is a treasure trove of natural engineering, a catalogue of designs perfected over eons. We are only just standing at the doorway of this vast library of innovation. By allowing these unique ecosystems to be degraded or destroyed, we risk losing this library forever. Every species that goes extinct is like a book being burned before we have had the chance to read it. We would lose not only a creature of intrinsic wonder, but also the unique genetic knowledge it contains. The biodiversity of the deep sea is a non-renewable resource of information. Conserving these hadal environments is therefore not just an act of environmental protection. It is an act of preserving a priceless inheritance of biological and genetic knowledge, a legacy that holds untold potential for the future of science, medicine, and our understanding of life itself. The ocean's currents, the planet's hidden conveyor belt, move heat around the globe, shaping our climate and making life possible. Deep water forms at the poles as cold, salty water sinks, driving this global circulation and connecting surface and abyss. But melting ice caps now threaten this ancient engine, as fresh water disrupts the sinking process. If the conveyor slows or stops, the consequences, extreme weather, disrupted agriculture, global instability, would be catastrophic. The fate of the deep sea is tied to our own. Protecting these currents is essential for our future. Protecting the ocean is not just practical, it's a moral imperative. The hadal creatures, ancient and unique, have as much right to exist as we do. We are the first to witness their world and the first with the power to destroy it. With knowledge comes responsibility. We are now their custodians. Our choices reflect our character. Will we be exploiters or stewards? The deep sea's fate is a test of our wisdom and our legacy. The deep sea appears invincible, but its stability is its greatest vulnerability. Hadal life is slow to recover. Damage here is often permanent. Climate change, pollution and noise threaten these fragile ecosystems. The hadal zone, once protected by its remoteness, is now within our reach. Our actions in the coming years regarding mining, fishing and climate will decide its fate. We can either plunder this last wilderness or preserve it as a sanctuary. The choice is ours. As our submersible ascends, we leave behind the darkness and cold of the hadal zone. This journey revealed not just strange creatures, but the deep interconnectedness of all life. The ocean is a single breathing system. Every layer matters. Our new awareness brings responsibility. What lies beneath shapes our world above. Let us remember the resilience and fragility we witnessed. Our journey ends, but the greater journey, understanding and protecting the deep, begins now. The future of the ocean depends on what we do next. The hadal zone's creatures are perfectly adapted to their world, but not to our rapid changes. Our actions, pollution, emissions, resource extraction send echoes into the abyss. The fate of these ancient ecosystems is now in our hands. Our choices can destroy or preserve. We are the primary force shaping their future. The echo of our decisions will be heard for millennia. What kind of echo will we leave behind? Our journey has revealed a world of incredible deep-sea creatures. But wonder alone is not enough. We must pledge to protect the vast, vital ocean that sustains us all. Every action counts, reducing plastic, supporting research, and raising awareness. Let us pledge, here and now, to protect the deep for generations to come.